Hello from Ursuline College. Ursuline is a small women-focused liberal arts school in Pepper Pike, Ohio, which is a suburb of Cleveland, Ohio. Ursuline is a recognized leader in healthcare-related fields. My name is Lynn Ulatowski, and my colleague Lita Yu teach cellular and biochemical processes lecture and lab, respectively. Like many of our upper division courses, the lecture material is supported by laboratory experiences. We worked closely to engage the students in some extended independent research that they are sharing with you today. In the laboratory, Dr. Yu focused on introducing and reinforcing technical skills used in cellular and biochemistry laboratories, along with scientific experiments. The semester culminated with student groups creating their own curriculum-based research experience, or CURE. In groups of 2 to 3, the students chose an experimental method that they learned throughout the semester and extended the experiment by changing and investigating 2 parameters. The students were then tasked with writing a protocol, ensuring that they had all the materials and equipment they needed, followed by several weeks of data collection. The students were responsible for taking their new ideas from concept to presenting a research poster at the Ursuline College Research Symposium. This was an incredible feat for a one-semester class. Today we present to you Nora DeKemper, a junior biology major who plans to pursue genetic counseling. Paige Jankowski, a junior biology major. And Endiyah, a junior medical laboratory science major. Nora, Paige, and Endiyah compared common nutrient supplements, vitamins K and E, and aspirin to analyze their anticoagulant properties.
Hello, my name is Endiyah. I will start with introducing our experiment on the effectiveness of preventing blood clots. The process of coagulation or blood clotting is our body's way of protecting itself from excessive bleeding when a blood vessel is damaged. However, too much blood clotting can be a cause for concern. There are a few pharmaceuticals shown to prevent blood clotting called anticoagulants. Low-dose aspirin is a popular daily supplement. Studies have also shown that vitamins K and E both play a role in the clot prevention process. My colleagues and I have hypothesized that low-dose aspirin would prove to be the most effective in preventing blood clots. With that, we conducted an experiment to compare the effectiveness of the 3 supplements. To perform our testing, we gathered controls based on the solubility of each substance. For low-dose aspirin, we used saline solution, and for vitamins K and E, we used acetone. When performing our experimentation, we added thrombin, a coagulant, to whole blood, then treated it with each supplement solution. We performed a qualitative measurement in which we observed the thickness and length of each clot using the slide method coagulation test. From that, we were able to convert those measurements into quantitative values, where we observed the time to first clot appearance, in which a slower clot time would indicate that the treatment was more effective. We also measured the number of clots, in which a low number of clots would indicate that the treatment was more effective.
Hello, my name is Nora, and I'll be explaining our results. In figure 1, we observed the average time for each sample to clot. And as you can see, aspirin took significantly longer to clot than its control of saline. And this indicates its effectiveness as an anticoagulant. In figure 2, we illustrated the range of clot strength based on thickness and length observed during the coagulation test, with 1 being assigned to the weaker, thinner, and shorter clots, and 6 being assigned to the stronger, wider, and longer clots. Just below it, figure 3 is the representation of the values assigned to those clots. Vitamin K did produce weaker clots than acetone, its control, and vitamin E produced stronger clots than its control. Aspirin and its control had no significant difference in clot strength And in figure 4, it shows the average number of clots each sample produced during its coagulation test. Vitamin K and E had similar clot number averages compared to its control, while aspirin showed significantly less clots than its saline control, which reinforces our hypothesis of aspirin's effect in preventing blood clotting.
Hi, I'm Paige, and I will be talking about our concluding thoughts and future possible research. In conclusion, our hypothesis was that low-dose aspirin will be the most effective in preventing blood clots. And referring to our data, aspirin took 2 times longer to begin clotting than vitamin E and vitamin K. Also, the treated blood with aspirin took longer to clot than its saline control, which supports our hypothesis. Aspirin showed about 60% fewer clots in the coagulation test compared to vitamin K and the control with saline. Our limitations of the experiment were the need for 2 controls being saline for aspirin and acetone for the vitamins. And that was based on the solubility of aspirin and the vitamins. In the future, it would be important to find a solvent that can dissolve both aspirin, vitamin K, and vitamin E. Another limitation is the anticoagulant solutions were not equal concentrations. The concentrations were based on what people would normally take. In the future, we would compare the similar concentrations in supplements. Our takeaway from this experiment is that there are alternative anticoagulants other than aspirin, such as vitamins. It would be interesting to continue research for vitamin E and K because they have other roles in the body, including being able to improve immunity, help growth, and help metabolism. But overall, we hope you enjoyed our experiment and our presentation. Thank you.